Okay, in this video we're going to be discussing for loops. It is the last type of loop that we are going to be looking at in Flow Control 2. Keep in mind there is a for each type of loop. We will be looking at that in a later section. Alright, so for loops. Let's go ahead and jot it down and then take a look at the syntax. For loops. Alright. Basic syntax is, this is a little bit more involved than the do and the while loops. We have for, open parentheses, an initializer, or you could say initialization. I like to call it an initializer. A terminator, your conditional expression, so condition. A terminator, and some sort of operation. And there you go. Then an open curly brace, your code to be looped, and finally your closing curly brace. This is the syntax. Now, check this out. The initializer is optional. The condition is optional. The operation is optional. What is not optional is the terminator and the terminator. So you could simply have for open parentheses, terminator, terminator, close parentheses. That's completely valid. But that means you are responsible inside of that loop for making sure that whatever occurs, you don't get yourself stuck in an infinite loop. Right, Logan?
Right, because if you don't put any initializer, condition, or operation, then you have just made an infinite loop.
Right. All right, so let's go ahead and write out an example so that we can see exactly what initializer, condition, and operation really means. So let's come over here like we've done in the last couple of videos. For, open parentheses, int I equals 1. Terminate. Alright, so that is our initializer in this case. Our condition, I less than 5. Terminate. Okay? That is our condition. Finally, I plus closing parentheses. That is our operation. Now let's go ahead and do an opening curly brace, and I'll simply have Logan do a right line that does the standard I equals plus I. And then we'll close this off. Just like with the do and the while loop and with if statements, having these open and closing curly braces in there are, of course, optional if there is only one line of code to execute. It's just like all the rest. Okay? So, with this example right here, here is what happens. Code execution is cruising along. Over on the stack, of course, we have... Why do I keep making it so small? That's going to make it hard for me to write in. I don't know why I do that. All right, let me fix that. So we have a variable that gets declared called I. Okay? And it is initialized with the value 1. Over here is our console once again. All right, so here's how it works. We hit the for loop. So the for keyword, we come over here into this. We initialize I to 1. That has now taken place. The next thing that we're going to do is we are going to run our conditional check. Is I, which is a value of 1, so is 1 less than 5? Answer, true. Just like with the do loop and the while loop, as long as our expression evaluates to true, we are going to do the contents of the loop. So in this particular case, we simply come down into the loop and we execute all lines that exist within those curly braces. So we're going to write out to the console, I equals, and what is currently in I? It is a 1. Now, where are we at? At this point, we have fallen to the end of the loop. So at the end of the loop, this is what happens. We now come all the way over here, and we first visit the operation where we do I++. So what happens to 1? It is incremented by a value of 1. It becomes 2. All right? The next thing we do is we rerun our condition. We reevaluate it. So at this point is I, a value of 2. So is 2 less than 5? Answer, true. What does that mean, ladies and gentlemen? Do the contents of the loop. So again, we are back inside of here where we are going to write out I equals and the contents of I. So I equals 2. All right, there are no other lines to execute, so now we are sitting right here at the very end of the for loop. So once again, we loop back around, back up here to the top, and we run our operation. So 2 is incremented to a value of 3 because of I++. Next thing we do, this is just by design, by nature, how the for loop works. So we come over here and we reevaluate our expression. So the condition is I less than 5, which I is a value of 3. So is 3 less than 5? Answer, true. So we do the contents of the loop once again where we write out I is equal to and the contents of it. So I equals 3. We fall down to the next line, which is the end of the loop. So we loop back around up here to our operation, I++. So our value 3 becomes a value of 4. And we then recheck the condition. So is 4 less than 5? Answer, true. So we go back into the loop once again. And then we write out I equals, so I equals, and the contents of I is 4. So we are right here once again at the end of the for loop, which by nature it loops back around and it reperforms the operation. So 4 is incremented to a value of 5. So 5 is what is being stored on the stack in the local variable I. We then come over and we do our expression. We evaluate it. So is 5 less than 5? Answer, false. And if this evaluates to a false, now we actually leave out of here, and then we come all the way on down, and we continue running where we'll write out finished. Actually, let me just come in here and put finished, just like I did in the other 2 videos. All right. Wow. That is how a for loop works. And this is just the generic standard setup right here. Once again, all of the parts within the initializer, the condition, so initializer, the condition, and the operation are all optional. I can use one of them, I can use 2 of them, I can use all 3, or I can use none at all. We'll come back and play with that in just a minute. But first, Logan, let's go ahead and code this little example out and demonstrate to them it working exactly as we've demonstrated on the whiteboard.
All right. Jump over to Visual Studio where we can begin a console project. And now let's set up a for loop. So we'll start out with for. We'll set our say that our initializer will involve initializing the variable, or declaring and initializing the variable I to a value of 1.
Okay.
So we'll put in a semicolon, a terminator, then we'll move on to our condition where we check to see if I is less than 5. Then another terminator, and finally we have our operation where we will increment I by 1. And now we can put in our blocking for the for loop.
Okay.
Inside of this we'll simply write out the value of I, so console.writeLine, which says I equals, and then the contents of I. After that, we can jump below it, where we will write out finished. So once again, we'll do a write line saying finished, and then a console read line.
All right, let us see if it gives us exactly what we saw over on the whiteboard, because this is the same code. So let's do it. So I equals 1, 2, 3, 4, finished. All right, so 1, 2, 3, 4, finished. Coming back over to the whiteboard, and I equals 1, 2, 3, 4, and when we continued over here, what happened? It wrote out finished. I just didn't write it in. But you guys saw that it did indeed work. It worked just like we saw over with the while loop just in the last video. So very straightforward. It's just a little bit of a different understanding is required for how the for loop works when compared to the do loop and the while loop. Because those are really straightforward if you think about it.
Right. It's like those both have, they operate on only a condition. It's like in the for loop, you have the initializer condition in operation. In the do while and the while, you just have the condition. But what's interesting, if you look at all of the things involved in the for loop, is they include things that we had to do ourselves anyway in the do and do while.
Matter of fact, I can come in here, Logan, and while you're talking, just set this up.
Because, I mean, in the while or the do while, the first thing we had to do was some form of initialization for a value that we would use to keep track of the loop. So we were initializing something.
Right here.
We of course, were doing the condition as we were in all three loops, but at the end we were also doing some form of operation to affect I. So we were doing all three things in the case of a while loop. The for loop just says that if we want to go ahead, if we know we're going to need to do those three things, initialization, condition, and operation, it allows us to set up all three things directly within the loop itself, so we don't have to have any external supporting code for that loop to work.
Exactly. This loop and this loop up here, absolutely identical. The way they function, exactly the same. They both start out with an initialization of the variable I taking place, getting the value 1 in it. So right here, the very next thing that happens is an evaluation of an expression occurs, right here and right here. In both cases, it is indeed the very next thing that happens. So let's say they both evaluate to true. We then perform the code inside the loop. The code is performed inside the loop. The last thing we do here is we simply increment I. Well, what did we do here? After that last line, we came back up and we incremented I. So the exact same steps happen. So these are, in essence, identical. But what Logan was getting at a second ago is using the for loop it's really a lot more straightforward. It's a more convenient way to package a loop, if you will, as opposed to using a while loop where you kind of have things scattered about.
Because in the while loop, let's say, for example, you weren't using I for anything other than controlling that loop. In that case, it would probably be more efficient to use a for loop, because that way the initialization of I happens all within the loop, the main line of the loop itself.
That's right, and I can prove that. We had the lesson where we talked about variable scope, and one of the things we talked about was block scope. And, well, here is an example of block scope. We are declaring and initializing I inside of our for loop, okay? So what happens if we were to try to come outside and print out whatever is in I? So I equals what? And this is all part of this top code. So I equals what? Well, I is created in this block structure up here. It is. It's being created inside here. And because of that, it is contained in there, and once the for loop is done, I is gone. Let's prove that to him real quick, Logan.
Okay. So what would happen if we took out this line that was meant to print out the value of I, copy it, and paste it outside of the loop? What would happen?
We can't even run it. Let's just compile.
Can't even compile.
Yep. The name I does not exist in the current context. Because of the scope of I, because it has block scope and not local scope, it is now gone. But this now brings us into another discussion, and that is, remember how I said that our initializer, the condition, and the operation are all optional. And we can, of course, tweak them, if you will. And what I mean by tweak them is, let's go ahead and instead of declaring I right here, let's declare I right above it, Logan.
Okay. So we could just completely say, cut that out. Well, I'll have to paste part of it back. But if we declared I above the loop, then went into the loop, and for the initializer, simply set I to 1. So now this is this I that was declared outside of the loop. And then we...
Now check this out. He's going to compile. This is really interesting, too, when talking about scope. In this particular case, the compiler is going to build it just fine because it knows that no matter what, this will get hit. If I never got initialized until we fell inside of the for loop, then the compiler is going to say, no, I don't think so, thank you, because we don't know if we're ever going to fall into the for loop, because remember, the way the loop works is the first thing that occurs when we hit the for line is the initialization. The second thing to occur is the test to see if we even need to run the loop for the very first time, meaning that there is indeed a possibility that the contents of the for loop will never be executed. So if we had come down here and placed our initialization, go ahead and take that and place it right above the console.write line and a terminator. Let's go and compile that. Now check it out. It's going to be very unhappy with us. We're using an unassigned variable. Well, actually, we're using it real quick because it needs to turn around and use it right here. But what I'm getting at is if we had, go ahead and do an int j. So, no, I'm sorry, an int I and an int j.
Okay, so we need another variable.
Yeah, just to prove my point real quick.
Int j.
Okay, now let's go ahead and check this out. Go ahead and initialize I right there. All right, so now I is initialized, so it's not going to be a problem whatsoever. Drop down into here. Let's just change that I to a J. All right, so follow me through, guys. Here's what we've done. We've come through, and we have declared an initialized I in a different location than within the for loop. We've done this in this particular case because perhaps we want to use the I later on in our code. So we did it outside of the for loop structure itself. So we've initialized it. We've come down here. We've created J. J has never been assigned. Now we fall down here into our structure for the for loop, and J gets assigned right there. If we come over here, and I'll reach across Logan and grab the keyboard real quick, and try to access J when we come out of the for loop, go ahead and compile. We've got a problem. Use of unassigned local variable J. But wait a minute. No. I have a problem here. We are indeed initializing J. Well, the compiler says we don't know if we'll ever make it into here. So right. Because of that, it's just going to assume there's a possibility that you could end up down in here with an uninitialized variable.
Right. Because it's not going to evaluate the entire for loop while compiling. It's just going to look at this and say, it is possible that we could write the for loop in such a way that this code would never be executed, and if it never was, J would be uninitialized right there.
That's right. Okay, so there you have actually seen us in a situation, Bink, where we have, I'm just going to do that to kind of, make it a little easier to read, where we've pulled our initialization out of here and we have put it elsewhere. Again, like I said, this is optional. But the cool thing is now if we come down here and we say write out the contents of I, remember a minute ago we couldn't because we lost I's scope because it was limited by block scope for the for loop. Well, now, since we have initialized it out here, we're going to see it as a local variable. So it has method level scope. And because of that, when we get down here, we can still see it. The interesting thing is, at this point, what is the value of I going to be? Well, we come down, it's a 1. Is 1 less than 5? Yes, it is. So we're going to print it out. We come back up here. We now increment it. Is it less than? So we keep going through 1, 2, 3, 4, and then let's go ahead and run. Watch this. 1, 2, 3, 4, I equals 5. This is that new line that just ran. As a matter of fact, let me make it a little easier to see. Just so because it does kind of look like we are inside the loop still. Ha! That'll make it easy to tell that that's not inside the loop no more. So, boom. 1, 2, 3, 4, and we know, based off of the whiteboard discussion a few minutes ago, that's what we're going to get from inside the loop. Now we're outside the loop, and we can see that, well, I was indeed set to a value of 5, and that's what caused us to jump out of the loop, and here it is. We still have access to the value. So this is really handy if you are writing some sort of logic that requires a variable, and you're going to run through the loop so many times, and then by the time you get to the end of the loop, you now fall out of the loop, and you need that number for something. You need to know how many times you went through it. So all I would have to do would be, watch this, Logan, say, we looped, and then put I minus 1. Oh, sorry, that was me and Logan fighting over the mouse. That's funny. All right, so go ahead and put these inside of parentheses.
So you have some parentheses.
And then let's append to the end of this, so go and add times. So here we're actually using this to tell us how many times we looped.
Let me take the equals out of that, so that makes a little more sense.
Yeah, we looped how many times? Well, if we have 5 minus 1, it'll be we looped 4 times because we executed this code internally 4 times, and we can prove that because of the write line that occurs right here. So let's go ahead and run this, Logan. So there we go. 1, 2, 3, 4 times the loop executed. We looped 4 times. Finished. So there is an example of us needing access to the variable that's being used as the control variable for the for loop, and us needing access to it after the loop has completed doing its thing, right? So let's see, what else? All sorts of good stuff that we can show here. All right, with that being discussed, Logan, let's go ahead and switch gears. Something that they haven't seen, and this is doable with the do loop, the while loop, and the for loop, but let's do it just once. Let's switch our logic up here so we count backwards.
Okay.
Because the key thing to remember is it's all about the condition evaluating to true or false. As long as the condition evaluates to true, the loop internals will run. So let's go ahead and start out by doing int I equals 10. And you can go ahead and take the equals 1 out up above just to keep it clean.
Do you want to completely take
the
just
take it out and
declaration?
put int I
All right, we'll
equals.
move it back to being declared within the for block instead.
Okay.
Just for clarity, I'm going to also remove the int j.
And the line down there with we logged so many loops, or we looped so much. Yeah. So we're just keeping this simple.
All
right, so now we're going to start at 10. Now, check this out. When putting the logic together for this, well, we know we want it to count backwards. So we'd probably want to come over here next and change that to minus minus. Okay. So now we're counting backwards. That's good. So we'll start out at 10, and we check to see, is 10 less than 5? No. We probably want to change our logic here.
Right.
What if we wanted to count down to 0?
We would want to set this to, do you want to reach 0 or do you want to stop when we hit 0?
Let's reach 0.
All right, so I would have to say is greater than, well, there's 2 ways I could do this. I could do this is greater than negative 1.
Greater than or equal to.
Or I could do greater than or equal to. That might be a little bit easier to read.
Yeah, exactly. So as long as I is greater than or equal to 0, then we're going to do the contents of the loop. So we start out at 10. That's number 1. Number 2, we do our evaluation. Is 10 greater than or equal to 0? Yes. We now do the contents of here. So we're going to say I equals 10. Come down here, which forces us to go back up here. Subtract 1 from 10. It becomes 9. Is 9 greater than or equal to 0? Answer, yes. We come into the loop and we execute its code. I equals 9. You can now see us counting backwards. We continue to do this when I decrements all the way down to 0. So let's just pretend it went from 1 to 0. We come over here. Is 0 greater than or equal to 0? Yes, it is equal. So we come down. We say I equals 0. We're at the end of the for loop, forcing us to come back up here and decrement I to a negative 1. With it becoming a negative 1, is negative 1 greater than or equal to 0? No, it's less than 0. We exit out. So Logan has just put together a simple for loop that will go 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. So let's go ahead and run it. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Blast off instead of finish. There you go. So you guys can see how this works. So I just wanted to show you real quick. You can count forwards. You can count backwards. Shoot. Let's have a little bit of fun. You guys up for some fun? Because at this point you've seen the basics of how the for loop works, which is the objective of this video. But let's do some other things. How about, since all of these are optional, how could we write a functional for loop that leaves all of these empty? This is just example time. Let's see. What if I was to do something like this? Let me think. I'm just going to give myself a little bit more room. That was horrible. All right, this is bonus stuff at this point, guys. So, what if I started out and said, let's go ahead and create an int. I set its value to 1. And then I said for, and I leave my initializer blank, so I put in my semicolon. I leave my condition blank, so I put in my semicolon. And I leave my operation blank. Okay, so I do that. Now I do my opening. Now in here, I'm going to do the conditional check myself, because what's the first thing that happens? We do a check. If I is greater than, and I don't know, just pick some number 4. That'll let us go all the way up through 4, just like we've been seeing. If it happens to be greater than 4, a new keyword, ladies and gentlemen, and we're going to be looking at this a little bit more in the next video, but we're going to break out of the loop altogether. Else, now I'm going to go ahead and put my opening curly brace right afterwards because I'm very limited on space here. So just pretend it's right up underneath it. But else, what are we going to do? We're going to write out I equals and plus I. And then we're going to do our I plus plus. And then we are going to close this off and close this off and pretend that the very next thing was finished. All right, there you go. We are controlling this loop ourselves completely. If you think about it, we've got our initialization being handled outside of it. The for loop just says, look, man, let's just start looping, okay? We're going to loop forever. We've got that infinite loop that Logan did at the beginning, which means it's our responsibility as the programmer to make sure we have some way of getting out of that loop. We then come in here and we say, all right, well, let's check right away. Is the contents of I greater than 4? Well, I starts off initialized to a value of 1, so no. All right, well, we're going to fall down here to the else, and we'll write out I equals 1, and then we'll increment I. Then what happens? We hit the end of our for loop, which forces us to come back up here. Well, there's no operation or anything to test, so we simply fall down into the for loop because it's an infinite loop now. Is I greater than 4? Well, no, it's been incremented to a 2. So let's go down to the else and write it out. Increment, and then up. So we keep doing this until finally we've printed out I equals 1, I equals 2, I equals 3, I equals 4. And then we come down here and we increment I to a 5. We come right back up to the top again. We fall through. Is I greater than 4? Or excuse me, let me back up. I skipped right over 4. Is 4 greater than 4? So we printed out 1, 2, 3. And is it 1, 2, 3? Yeah. And then is 4 greater than 4? The answer is no, 4 is equal to 4. So now we are going to break. So actually, we'll make this 5 to make it read better. You see what I'm getting at, Logan?
Right, because you want to make sure we get...
I want to get the same results with all of the examples
the same
we've
output.
used. But with it being 4, the bottom line was when I is 4 greater than 4? No, it's equal. So it would break out because we do the true portion of this if statement, which means we come all the way down here and we write line finished. But by putting it as a 5, this for loop right here will act just like the while loop that we demonstrated in the last video, except, once again, we're controlling everything ourselves. Let's go ahead and put that together real quick, Logan, just to demonstrate it.
Okay. To do this one, I'm going to start by wiping out the entire board. We'll just start over, and let's declare a new for loop. So we can do
some fur. All right.
For 2 terminators, and then block this in.
Okay. So let's go above the 4 real quick and initialize I.
Oh, yeah, I almost forgot about our index variable. Let's declare an I variable initialized to 1. Then let's turn around inside of the for loop and do our condition. Let's check and see if I is greater than 5. If I is indeed greater than 5, I'll just do standard blocking with everything like this. I don't remember in yours. Did you have
we can do,
a line after?
That's perfect.
Okay. So we want to do a check. Our condition, what should we do if I is greater than 5? We will break. And
the answer is no. Over in mine, I did not have the opening closing, only because I was so limited on space.
I did notice that you were at the very bottom of the screen and all.
Yeah.
But all right, we've got our condition. Now we want to set it up so that if a condition was not met, we instead want to write out to the console. So I'll plug in an else, and inside of that else, we will do a console write line where we can write out the value of I. So I equals plus I terminator. And we also want to make sure we increment I, and that should take care of the loop. Let me do a build. Everything looks good, so we should be able to...
So go ahead and run it. And 1, 2, 3, 4, and 5. Now let's see, where are we getting our 5 from? Let's go ahead and close that out and jump back in here.
We could trace through, or let me see, we've got... Probably because incrementing doesn't happen till down here.
Yeah, exactly. So, wow, this is what happens when you do this really late. As a matter of fact, watch this. Let's pretend that someone's following this and they don't really have a clue as to what's going on. I love doing that because that is most important here. Just in case somebody else is having a hard time with the logic, let's go ahead and put a breakpoint in and walk through this.
Sure.
So we come in here, we are switched over to locals down here, we're watching I. I is already set up as a 0 because of our prolog code, but let's go ahead and run the line, which is going to initialize it to a value of 1. We're now, look at this, we're automatically inside our loop. Let's go forward. All right, so is 1 less than 5? And let's go ahead and go. No, it's not.
So it's not.
So we're going to write out.
And we'll write out.
And then let's go and increment. All right, so we jump back around. All right, so now I is a 2 is 2 greater than 5, and answer is. So again, it falls down through, and then again, and now here we are with 3, so it's 3 greater than 5. No. So we increment it to a 4. So we go back up. Okay, let's continue. So is 4 greater than 5? So keep on going. And then we're going to write out and increment to a 5. So let's go back up. Now,
is 5 greater than 5?
Is 5 greater than 5? Let's see what we've got so far. So we've got 1, 2, 3, 4. And let me come back over here and look at this. All right. So go ahead and run this.
So is 5 greater than 5? No, 5 is not greater than 5. So instead, write out 5.
That's right, because what is 5? 5 is equal to 5. So we're going to write out what is in 5, and now let's go back through and back up.
So now we have 6.
And now it's 6. Is 6 greater than 5? Answer is yes. Fall into it. Aha, break, and now run. And then we're going to print out finished and read line. So go ahead. Well, I'll just finish this up here. And this is why we get 1 through 5, which is awesome, Logan, because when I was first writing this out, my logic was right.
Right, you did have the 4 in place.
I had a 4 in place. It's just funny how you can talk yourself. I mean, that was a great example, and that's why I wanted to go ahead and just kind of push forward with the showing them the walkthrough right there. Because at first, when writing this out, my brain spit the logic out right, but then when I went back through, I actually questioned myself just because
I think the reason it was tricky is because in the for loop up until now, if we trace through it, what happened is after the first iteration, the operation happened before the condition.
Right.
The way we had set up this loop, the condition always happens before the operation.
That's right.
So we were doing the same kinds of checks, but we ran them in a different order because we were running them ourselves.
Exactly. But that brings up another beautiful point. You'll notice that the way we are setting this for loop up, we are all, it's really interesting. Right? Before I even say that, let me back up. With the do loop, the contents of the loop is always guaranteed to execute one time, for sure. With the while loop, the contents are not guaranteed to execute one time because you could come in with a condition that evaluates to false. And so the while loop just simply skips over and you continue with execution and nothing is looped, not even one time. With your standard for loop, there is, or let me just say, with the for loop, there is also, it's just like a while loop, no guarantee that the code inside will execute once. None at all. But by breaking the for loop up this way here, we can control it so that the contents will always execute at least one time if we want to, can't we?
Right, because the loop is set up to always execute. That means it's always going to get into inside the loop.
Precisely. So if we were to come in here and rearrange our logic by taking our if statement and putting it at the end, then we could do all of the code that we wanted to have occur within the loop, and then at the if say, all right, if this has happened, let's just jump out of here. So that is a way for us to take a regular for statement and have it mimic a do loop, okay, by us controlling when we're going to break out. Anything you want to add to that, Logan?
No, just that you have a lot of flexibility because all of the initialization, condition, and operation are optional. That gives you a lot of flexibility because you could use all, like you were saying before, all of the things provided by a for loop, some of them or none of them. It's up to you.
That's right. And we can have a little bit more fun with this. Wow, the fun just never ends. Right now, we've been just putting in, variables, int I equals 5, and then is, a very simple expression, I less than 5. We could do function calls. We can call a method that returns a value as well. Now, I know this maybe goes beyond the scope, but hey, let's take a look at it, right? Because we're right there at it. What if inside my for loop, for my initializer, hang on, let me look for a place where I can write. I got lots of good stuff going on here. What if I had some sort of function called init, we'll do it with a capital I. So we had a method that we called on for initialize, and a method that was called cond for condition that we called upon for condition, and OPR. I'm just going to make something up. a method that we called on for the operation. And inside these methods for the initializer, it could take a look at various states of an object. It could do all sorts of things to initialize the number to an appropriate number.
Right, that's the key. The initializer, condition, and operation, they aren't set up to require anything specific. Each of them can run arbitrary code. It's just set up, you just have to keep in mind what's going to happen first. That on the first iteration, the initializer is going to hit, and then it's not going to get hit on every subsequent iteration.
That's right.
Then you have things like the condition, which gets hit every iteration, and then things like the operation that gets hit every iteration after the first one. So all you have to do is keep in mind at what point each of those get called, and after that it's up to you to put whatever code there you want.
Exactly. So in this case, the initializer would make a call over here to the initialize method, and that would return, let's say, an int back. And then when at that point, we would then come over here to this guy, which would make a call to COND, and that method would return back a true or a false, a bool. And then from there, we would do whatever we needed to in the code if it was true. When we came back up here to our opper, then what we're going to do is do a method call to that, where that is basically going to, let's say, send us a value back that we're going to increment our number somehow. Okay, let's build this real quick. Why not?
Okay, I'm going to set up a scenario, though. I'm going to do something a little bit differently, though, just to be... Actually, no, let me try setting it up with local. I was thinking that for a second I'd have to give private scope within the class. Mm-hmm. Let me just try setting this up. Let me make some methods that we could potentially use for things like initialization, condition, and operation.
Sure. Guys, just to let you know, this isn't anything that's been pre-scripted. We're just adding some bonus material once again.
Bonus section 2.
That's right.
So let me define some methods. Let's see. Let's have a static void method called init. Let's see. Yeah, I'm going to do this. Let me define I out in private scope in the class itself. I'm also going to make it static, following the same rule we have with the methods themselves, so that we can use this from within the static main. So we've got our I now as part of the class itself. That's why I can easily use it here.
So class level scope, we can see it in all methods.
So inside of init, I could do something familiar like set I equal to 1. Let's make another method now, a static. This time I want to return something. This time let's return a bool for test, or you had condition.
Condition. Uh-huh.
Let me go all out with the naming.
Okay.
Check condition.
So make that C capital. All right.
So check condition, and from here, of course, let's return some boolean. So let me return an expression. Let me return I greater than 5. So we'll evaluate this expression, which is going to return true or false, and pass that on through the return through the method itself. And then finally, let's do one more static, this time void method for do operation. And in this, we will increment I. Let me build to make sure I haven't introduced any problems with these methods, and everything is looking good. So let's rewrite. I'm going to go ahead and wipe out your example here.
You go for it.
And let's write some things into this for loop. Let's save the initializer. We call init. Then for the condition, we run check condition. And for the operation, we do a call to do operation. And inside of here, let me put in a console write line, so I can write out the contents of I. We'll do the standard I is equal to, and then concatenate onto that I, like so. Let me do a build, make sure that everything is good. Let's run.
And hang on, and you're going to get finished because you're going to start out with a false in the condition right away. Go ahead and change your logic to is I less than 5.
Okay. Yeah, I was trying to combine your example with my example to make a hybrid that didn't do anything.
Right.
So that was fun.
Okay, so I starts out at 5. Look at this. Logan has recreated the exact example we've looked at with the loop, the while loop, and the first example with the for loop, where I goes 1, 2, 3, 4, and then we jump out, finished. But the key thing in this particular case, which is really interesting, is Logan is using method calls, functions that return information back to control the loop.
And what's cool is what this means is that you could potentially use a for loop to cause some other algorithm to function. For example, if we went into check condition, or even, let me do the in the operation one, we could do something like another piece of code, like a write line. Say, we are performing the operation. So some arbitrary piece of code. So we can see that we are hitting that method every iteration of the loop. So this method could be something else, like cause an enemy to spawn or to chase you or to die.
Exactly. So basically we have even greater flexibility now.
So yeah.
Okay.
Very cool.
Well, that's pretty much everything we want to show you for the for loop. I know it's a little bit above and beyond just the standard that you normally see in books and all, but hey, it's good stuff, and I'm sure we're going to be using a lot of different for loop configurations as we work our way through a bunch of the different projects. Just the key thing to remember is that with the for loop, there's an initializer, a condition, and an operation, and the three guys are separated with semicolons, and all three of them are optional, but the semicolons are not. They must be there no matter what. And as long as the condition evaluates to true, we will do what is inside the loop. So with that, that is going to wrap up this video on for loops. Thanks a lot, guys.